Have you ever been stuck in a coding project where everything seems to work at first? But then you make one tiny change and suddenly everything breaks. Or maybe you have faced a code base that seems impossible to understand or maintain. If you have been there, you know how frustrating it can be. I have been there too. Early in my career, I did not focus much on design principles like Solid. But as I wrote more code and worked on bigger projects, I realized that these principles make a lot of sense. They can make your code more maintainable, scalable, and easier to understand. That's why today we are going to discuss or talk about solid principles. These 5 design principles were introduced by Robert Martin, also known as Uncle Bob. By the end of this video, you will know how they can help you build cleaner code and avoid these coding headaches. Let's dive in. So what are solid principles? Solid is an acronym for 5 design principles that help you write cleaner and more maintainable code, as I said earlier. Those are nothing but single responsibility principle, also known as SRP, open closed principle, Liskov Substitution principle, interface segregation principle, and dependency inversion principle. So today, let's dive into each one with examples to understand how they can work. Single responsibility principle. The single responsibility principle states that a class should have only one reason to change. In other words, a class should do only one thing and do it well. Here's an example of God class that violates SRP. This class, report manager, does everything. It generates reports, sends emails, and serves them to a database. This is problematic because a change in the email logic could break the report generation or a database saving. Now here's where we can refactor it to follow SRP. We need to separate the responsibilities into 3 distinct classes: report generator, email sender, and database saver. Now each class have a single responsibility and changes in one won't affect the others. Open close principle. The open close principle suggests that the classes should be open for extension but closed for modification. This means you should be able to add new functionality without changing the existing code. Now here's an example where we have a shape class with a draw method. If we want to add a new shape, we need to modify this class, which violates OCP. So in order to fix this, we can use inheritance or interfaces. So instead of modifying the shape class, we create new subclasses like circle, square. Now to add a new shape, we just need to create a new subclass without touching the existing code. Liskov Substitution principle. The Liskov Substitution principle says that objects of a derived class should be able to replace objects of the base class without affecting the program's behavior. Essentially, subclasses should behave in a way that's expected from the base class. Let's take a look at an example. Here's a bird class with a fly method. We create a penguin subclass, but penguins can't fly, leading to unexpected behavior if you expect all birds to fly. So this violates LSP. In order to fix this, we should rethink the hierarchy. So instead of having all birds with a fly method, we create a flying bird and non-flying bird hierarchy. This way, penguin can inherit from the non-flying bird without violating the expectations. Interface segregation principle. The interface segregation principle advises that it's better to have many small interfaces than one large one. This helps prevent classes from implementing the methods they don't need. Here's an example with a large interface worker that has methods like work, take break, and manage. If you have a simple worker who does not manage, they still have to implement the manage method, even if it's empty. So to fix this, we create smaller interfaces like worker, break taker, and manager. Now, a simple worker only implements what they need, while managers can implement additional responsibilities without affecting others. Dependency inversion principle. The dependency inversion principle promotes loose coupling by ensuring high-level modules don't depend on the low-level modules, but it depends on the abstractions. This allows for easy testing and also flexibility. Let's take a look at an example. So here's a customer service class that directly creates an instance of email service. This creates a tight coupling and makes it hard to test or swap out the email service from something else. In order to fix this, we use dependency injection. So instead of creating the email service inside customer service, we pass it in through the constructor. Now the customer service depends on the abstraction, allowing us to swap in different email services or even mock them for testing. Alright, so here's an overview of solid principles with examples. By applying these principles, you can create code that's easier to maintain, extend, and understand easily. I hope you found this video helpful, and if you did, give it a thumbs up and subscribe for more coding tips and tutorials. If you have any questions or other topics you would like me to cover, leave a comment below. Thanks for watching and happy coding.